All right, let's take a look at our first proof here. Number 5, we are to write a 2-column proof for the following situation. So we have a quadrilateral here. We are given several items. We are given that the length of AD is 8, the length of BC is 8. We are given that segment BC is congruent to segment CD, and then we are trying to prove that AD is congruent to CD. So, a couple things. The givens we will almost always write at the very beginning. What you're trying to prove, this is always your last statement. So if you jump ahead, look at number 4 at the bottom. These are going to be exactly the same because you are ending with what you're trying to prove, so it always is last. So notice line 1, AD equals 8, BC equals 8, and then I squeezed in BC equals CD all in line 1. So that's given. Now, one thing I want us to get in the habit of doing, let's mark tick marks and angle marks on our proofs as we can. So it says BC is congruent to CD, so let's go like this. BC, CD's at the top. And then let's label AD as 8, and then BC is 8. Okay, now I'm not going to put 8 up here just yet. I may need to do that in my proof. I don't know, but let's just, I'd like to get everything on the picture because sometimes that helps us find more reasons. Okay, number 2. It says that the length of AD is equal to the length of BC. AD and BC. Okay, well, we know that that's true because we know they're both 8. So, but how did, like, what property, definition, reason allows us to do that? So if you look here, basically we can say that if BC and 8 are the same, I can replace 8 in this first equation with BC. So that got substituted right here. So number 2 is the substitution property. So you want to look at what's above in the proof and see how things got moved around and replaced and worked with to get to the next piece. Okay, segment AD is congruent to segment BC. AD and BC. Okay, well, I know that's logically true because they're both 8, but I need to get a reason over here. So look at line 2 and line 3. They're virtually the same, except these say that the lengths are equal and the segments are congruent. So this is going to be that same reason, kind of, as on the previous page, where we went from congruent angles to equal measures. So because if lengths are the same, that means the segments are congruent. This is another definition of, so it's not going to be definition of congruent angles because I'm not talking about angles. We're talking about segments. So it's going to be definition of congruent segments this time. So number 3 is definition of congruent segments. Definition of, and if you want to use the congruent symbol in there, you can. You know, you can use angle symbols, you can use equal signs, things like that. Okay, so we will see this a lot where it goes back and forth from segments being equal to lengths being equal or the other way around. Okay, so it looks like we're ready to finish. So there's only 4 lines in this proof. So where did this come from? So AD is congruent to CD. So if you kind of look up here a little bit, a lot of times it's a combination of earlier steps. So I've got BC congruent to CD. I've got AD congruent to BC. Okay, so maybe start here with AD. So I'm going to, over to the side, write this out so you can see it. AD is congruent to BC. Oops, I meant D. AD congruent to BC. And then I'm going to write this one. BC is congruent to CD. So I'm ending with BC and beginning with BC and going straight from AD to CD. That's our transitive property. You might think that's law of syllogism. It is. But it's the transitive property, and since that's a congruent symbol, it's the transitive property of congruence. Transitive property of congruence. So knowing these properties is going to be really important, because if you don't know the properties, then you're never going to recognize them in a proof. So that would be something to take a look at and try to work on studying. I'm going to try to get a Quizlet out there for you guys to look at. So I'll try to get that out in Schoology. Okay, let's do this last one. Number 6, M, given that M is the midpoint of AB, we're trying to prove that 2AM, this is 2 times AM, if you want, maybe put parentheses around it. So if I take 2 times the length of AM, it's going to equal AB. And that makes sense, right? If this is the midpoint, if I double AM, it should be the whole thing. Okay, number 1, M is the midpoint of AB. That is a restatement of the given. That is given. All right, number 2, segment AM is congruent to segment MB. So when you are doing a proof where you're provided all that, let's mark this on the picture as we read it. Segment AM is congruent to segment MB. All right, well, where did that come from? Well, if this is the definition, if this is the midpoint, isn't the definition of midpoint that the 2 lengths are equal? So if we say that the 2 segments are congruent, then that's just saying, well, that's just what the midpoint is. That's a definition. So it's a definition of midpoint. So that's the reason we'll write on number 2. Definition of midpoint. So when you feel like, if you're really reading through the given and the statements, if you feel like the next statement is just really saying in a different way what the one above it did, that's probably one of your definitions. So we're going to have a definition of all kinds of stuff. We could have a definition of midpoint, a definition of complementary angles, definition of supplementary angles. So if it just restates what it is, it's a definition. Okay, AM is equal to MB. So the length of AM is equal to the length of MB. These are almost identical. So I'm going from congruent segments to equal length. That's the definition of congruence. So definition of congruent segments. So let's use I'm going to use the congruent sign so I have enough room. Segments. Sometimes you'll see it written as just definition of congruence, which is fine. All right, AM plus MB equals AB. So I have an equation here. So let's go back to the picture and trace through that. So AM plus MB equals the whole thing. Okay, the sum of the 2 segments equals the total. We've studied that. That is a postulate. That is the segment addition postulate. Segment addition postulate. Okay, I'm going to run off my page here. Okay, segment addition postulate. Okay, AM plus AM equals AB. So that's not the segment addition postulate because it's the same segment twice. But look how close it is to line 4. Look how MB turned into AM. Well, the reason that happened is look at line 3. If MB and AM are equal, then you can replace one with the other. So substitution occurred. So this is the substitution property. Okay. And then finally, AM plus AM equals AB, and then we have 2AM equals AB. Well, this is just combined like terms to get down here. So usually we throw that type of thing into the word simplify. Things were just condensed on one side. Okay, and notice that is the very last line on the statement side. Okay, so this is our kind of our introduction to proof. We will continue to work on this quite a bit over the next few months. So as always, if you have questions, let me know.